Video, we're going to talk about how to solve exponential equations with natural logarithms. So another application of logarithms is to be able to solve equations like e to the x equals 17. So in this problem, notice we have an unknown exponent and the base is e. The opposite of e to the x is the natural log, so we can solve this problem by taking the natural log of both sides of the equation. So when we do that, we get the natural log of e to the x equals the natural log of 17. Well, since the natural log and e to the x are inverse operations, they're going to cancel each other out, leaving us with just x equals natural log of 17. And then what we can do to approximate x is just type natural log of 17 into Desmos, and we're going to get 2.8332 as our approximate answer. So now you can go ahead and pause the video and try doing this example on your own. So here we have e to the x equals 21. So I'm going to start off by taking the natural log of both sides, which gives me the natural log of e to the x equals the natural log of 21. The left side is going to simplify to x, so I now have x equals natural log of 21. I'm going to go over here to Desmos and type natural log of 21, and that's going to tell me that x is approximately equal to 3.0445. So when we have to solve exponential equations that have a little bit more problem solving involved, we're going to always start off by isolating the exponential term. And then you're going to take the natural log of both sides of the equation once that exponential term has been isolated, and then go ahead and solve for x. So let's try this example. We have e to the 3x equals 51. So the exponential term is isolated, so I can go ahead and take the natural log of both sides. So I have natural log of e to the 3x equals the natural log of 51. So on the left side, that's just going to simplify to 3x. And so I have 3x equals the natural log of 51. And then I'm going to go ahead and divide both sides by 3. When I divide both sides by 3, we have x equals the natural log of 51 over 3. I'm going to go ahead now and use Desmos to approximate this. So I have natural log of 51 divided by 3, and that's going to be approximately 1.3106. So now let's try this equation. We have 4e to the negative 2x plus 1 equals 55. So here you can see my exponential term is not isolated. So I need to start off by going ahead and getting that term by itself. I'm going to start off by undoing the plus 1 by subtracting 1 from both sides. When I subtract 1 from both sides, I get 4e to the negative 2x equals 54. Now I'm going to go ahead and divide both sides by 4. So when I divide both sides by 4, I get e to the negative 2x equals 54 over 4. And I'm just going to leave it like that. And I'm going to go ahead and take the natural log of both sides. So I have the natural log of e to the negative 2x equals natural log of 54 over 4. So now on the left side, that just leaves me with negative 2x. So I have negative 2x equals natural log of 54 over 4. That negative 2x I'm going to undo by going ahead and dividing both sides by negative 2. And now this is going to turn into x equals the natural log of 54 over 4, and that's going to be all divided by negative 2. So I can now use Desmos to approximate this value. So I'm going to go ahead and type ln and then parentheses 54 over 4. And then it's very important that I arrow to the right and then close the parentheses before I do the divided by negative 2, okay? Because that entire natural log is being divided by negative 2. So x is approximately equal to negative 1.3013, right? Remember, we always usually round to 4 decimal places. Now you can go ahead and pause the video and try doing this example on your own. So here we have 6e to the 5x equals 18. So we start off by isolating the exponential term. That 6 is multiplying the exponential term, so we have to go ahead and divide both sides by 6. That gives us e to the 5x equals 3. Then we take the natural log of both sides. On the left side, the natural log of e to the 5x will just become 5x. So we have 5x equals natural log 3, and then we divide both sides by 5. That gives us x equals natural log of 3 over 5, which we can approximate in Desmos as approximately 0.2197. So remember, the natural log can be used to solve exponential equations. Remember to first isolate the exponential term before applying the natural log to both sides of the equation.